This is part 3 on how to name chemicals, inorganic chemicals. And on this part 3, we're going to focus on how to name acids. Before we do, though, I'd like you to have your periodic table out, your detailed one, along with your polyatomic ion sheet. And I'd like you to try to review a little bit and check your own knowledge and see how well you do. I'd like you to name these 4 chemicals. And then, so stop the video right now at this point, name them on paper, and then turn the video back on and see what the answers are. Okay, now that you've had a chance to practice and try these out, let's see how correct you were. Okay, the first one, we have calcium, which is a metal attached to a non-metal, so that's the most basic naming system. And so that we'd write the name of the metal first, which is calcium. And then we'd write the stem of the non-metal, which would be chlor, and then put an IDE ending. So this is calcium chloride. The next one looks a little complicated, doesn't it? And as we saw before, that's because it has a polyatomic ion in it, which is called a nitrate. Let's look at our detailed periodic table and check that metal out there, cobalt, and see if it has more than one possible ionic charge. So we look at cobalt, and we see here that it could be a +2 or a +3. Your periodic table is probably clearer than this one, but it could be a +2 or a +3. So what do we do with that one? Well, I'll just write it out bigger here. CONO3, 3. We also need to look at the charge of the polyatomic ion, the nitrate. So we'll look at the nitrate, and we see here that that has a charge of -1. Now there are 3 of those, so this nitrate has -1 charge. But there are 3 of those, so -1 times 3 equals -3 total for this part. So that must mean that the cobalt, in order for this to be a neutral compound, it must have a +3 charge. So +3 added to a -3 equals 0, which is neutral. Okay, so cobalt has a +3 charge. We already saw that cobalt is a transition metal which could have more than one possible charge. It could either be a +2 or a +3. In this case, it's a +3. Since it is variable, we have to use a Roman numeral for the metal. So we'd write Roman numeral 3 after the word cobalt. So cobalt, Roman numeral 3. And then we'd write the name of the polyatomic ion, which is a nitrate. So cobalt, Roman numeral 3 nitrate, or cobalt 3 nitrate. The third one, we just write, it's just a metal, and then this right here we notice was a hydroxide, a polyatomic ion. So we just write the name of the polyatomic ion next to the name of the metal. So this would be potassium. And then the name of the polyatomic ion, which is hydroxide. CO2 here, that's not a problem, is it? A nonmetal hooked on with other nonmetal. So we use the mono-di-tri system. So that would be carbon, and then di, ox, and then we put the IDE ending. So carbon dioxide. Okay, so that's a little review. Problem is now, what if we had to name something like this or this? Well, we don't have naming systems for those yet. We don't have naming system because those, I can tell because there's an H in front of them, those need to be named as an acid. If we're assuming that they're dissolved in water, then we're going to name them using the acid naming system. So this particular part 3 deals with naming compounds that are acids. So naming acids. Okay, now we have two different naming systems for acids. One is if the acid does not contain oxygen, and the other one is if it does. The best way, I think, to get a grip on this is to look at some examples. So let's look at an example, HCl. Very common acid. We've used it already in class at the beginning of the year. Okay, we can tell it's an acid because it has H as the first term. Okay, that's a good indicator right there. And we're going to name it as an acid, assuming that it's dissolved in water. Okay, if it was a gas, we wouldn't name it as an acid necessarily. But if it's dissolved in water, we would. So how do we do this? Well, what you do, since we know that there's no oxygen in this one, we use the first naming system. First acid naming system. And that is, you put the word hydro as your first term, so hydro, and then you put the root or the first part of the second term there, which would be chlor, hydro plus chlor, and then you put ic after it, so plus the word ic, so hydrochloric, and then you write the word acid. So this would be hydrochloric acid. Okay. Well, there are other acids like that too. Okay, what if we had something like this? HBr. No oxygen, so we'll use this naming system here. Put the word hydro as our first term, hydro, and then write the root of the second, the nonmetal, or I should say the halogen here, which would be brome, and then put the little suffix ic there, so hydrobromic, and then we'd write the word acid. So that's the first acid naming system, one where there's no oxygen in the compound. The second naming system, the second acid naming system, is used when there is oxygen, in the compound. Okay, let's take an example. What if we have something like H2SO4, a very common acid, one that we will be using in this class? See, it has oxygen in it. Maybe I should put has oxygen. It has oxygen, so we're going to use the second naming system. So how do we do that? Well, we look at the polyatomic ion right here. Okay, so what is the name of that polyatomic ion? Are you looking at your chart? It's a sulfate, right? So this happens to be a sulfate ion, not a sulfite, an 8. Okay? And we find that this naming system, let's contrast it with the other one. Let's say we have H with a sulfide on it, so H2SO3, where this right here is the sulfite ion. Let's contrast the two, and that'll make it easier to learn. Okay, what's the difference in the naming? Well, both of them have oxygen. With this one here, since the polyatomic ion ends in ATE, what we do is we replace the ate with ic or ric. We do not use the word hydro in front, like we did for the other acid naming system where we don't have any oxygens. With this one, no hydro. No hydro in front. Okay? Exclamation point. You don't use hydro. So, how do we name it? Let me just use a contrasting color here. I'll use red or something. Okay, so I know it has hydrogen in front, but you don't have to write the word hydro. So what you do is you write sulf. Now this is sulfur, right? So sulfur, ic, and you use the word ic if it ends in ate, and then you write the word acid next to it. So sulfuric acid. For the next one, H2SO3 contains a sulfite ion. That ends in ITE. If the oxygen-containing ion in the acid contains ITE, we don't use ic afterwards. We use OUS, or us. So this would be sulfurous acid. Okay? So H2SO4 is sulfuric acid because the SO4 is a sulfate that ATE is changed to ic. So some people, they would write sulfic acid, but chemists, they put that extra syllable in there, so it's really sulfuric. If, on the other hand, the oxygen-containing ion ends in ITE, you'd replace the ite with OUS, and so you'd have sulfus acid. But just to make it sound better, chemists call it sulfurous acid. Okay, let's try a couple more and see how you do. Okay, what if we have, let's look at the polyatomic ion chart as soon as I get the lights back on again. And we'll try to build an acid from that. Okay, well, let's see here. How about something with NO3 in it? So that would be NO3 has a -1 charge, so we just need one hydrogen to match up with it to make a neutral compound. So HNO3. And then how about building another one from its sister here, the nitrite, okay? HNO2. So we have two different acids. How do we name them? Well, what we do is we look at the name of the polyatomic ion. This one here is a nitrate ion. And this one here is a nitrite ion. Okay? You remember, if it ends in ATE, we name our acid by changing the ate to what? That's right, ic. And so this would be nitric acid. Notice that if the compound contains oxygen, we do not put hydro in front, do we? No. Let's look at the second compound, HNO2. HNO2 has a nitrite ion. That ITE ending needs to be replaced with what? That's right, OUS. So we end up naming the acid as nitrous acid. So in summary then, if an acid contains oxygen, we have two different choices. If the polyatomic ion ends in ATE, we change the ate to ic. We do not use hydro in front. If, on the other hand, the polyatomic ion ends in ite, we change the ite to us. We do not put hydro in front. The only time we put hydro in front is for acids where there is no oxygen in the acid. Now, it's time for you to look at a few here and see if we can name them together. Okay, here's one, HNO3. We just did that one, right? That would be NO3 is it ends in ATE, right? So that would be, we change the ate to ic, so that would be nitric acid. How about this one, HI? No polyatomic ion, there's no oxygen in there, so we have to use hydro in our naming system. So that'd be hydro, and then we use part of the word iodine, so iotic. You put the ic there, so iod and then ic, and then acid, so hydroiodic acid. Let's look for another one. Do we see any more acids? Something with an H in front? Yes, there's one. H2SO3. Oh, we've already done that one, but we can do it again. Okay, SO3 is a sulfide. It ends in ITE, so we change the ite to us, and so this would be sulfurous acid. How about this one here, H2S? No oxygen, so we have to use the word hydro, the prefix hydro in front. So hydro, it has sulfur in it, so it'd be hydrosulfuric acid. Okay? Now what I'd like you to do is to try a few. Oh, by the way, before we go any further, I forgot to mention, now this doesn't have to do with naming acids, but it's very important. There are two chemicals where we don't use the naming system. H2O and NH3, very commonly used in chemistry. Of course, we know this is water, right? And so we just write it as water. That's the chemical name for H2O. So do not name it dihydrogen oxide. It's totally unnecessary. It's just water. The other really common chemical is this one, and it's called ammonia. Do not name it nitrogen trihydride. Name it ammonia. So these are the two exceptions where you're not using those formal naming rules. You just, H2O is water and H3 is ammonia. Thanks, I had to get that out of my system. Okay, time to practice. Do you have your periodic table and your polyatomic ion sheet? Good. Let's try a few of these. Okay. So, once you have it ready, we don't need to write the reason down. Cross that off. But what I would like you to do is write the chemical name next to the ones where the chemical formula is given, and then write, if the chemical name is given, write the chemical formula down. And let's say we're going to do it for the first, I don't know. Let's do all of them. Why not? It'd be a good practice. Ready? Here we go. Now stop the video and do it on paper. And then once you're done, turn the video back on and you'll see what the answers are. Okay, now I'm going to go through the answers. For the first one, it's just a simple metal with a non-metal. Okay, so I just use a simple naming system, magnesium chloride. For the next one, I see that we have a non-metal combined with another non-metal. So in this case, we use the mono-di-tri naming system. So this would be dinitrogen trioxide. For the third one, we have a metal and a non-metal, but I seem to recall that iron is a transition metal if you look at your periodic table, and it has a possibility of more than one ionic charge. It could be either a +2 or a +3. Now since chlorides are halogens with a -1 charge, we have 3 of those. That'd be a -3 for all 3 of these chlorides. That means that the iron must be a +3. I'll just write the reasoning here. What's the charge of iron? Well, we have 3 chlorines at -1 apiece. That gives us a -3 charge. Sorry about that. Gives us a -3 charge. So that means that the iron must be a +3. Okay, now remember, if we have a metal with a variable charge, we have to use Roman numeral. So this would be iron, Roman numeral 3, indicating its charge, and then write the word chloride. Do not put iron trichloride down. That's totally wrong. It's iron, Roman numeral 3, chloride. Okay, we have another one here, cobalt. Cobalt is another one of those transition metals with variable charge. COBr, bromine has a -1 charge, but there's 2 of those. 2 times a -1 gives us -2. That means that cobalt must be a +2. So we have to use a Roman numeral 2 after the word cobalt. And then we put the word bromide next to it. Cobalt, Roman numeral 2, bromide. Here we have a metal and a non-metal. So we just write it in the simplest way. No Roman numeral needed. This is lithium hydride. Here's one where we have the name of the chemical, but we need to write the chemical formula. Okay, copper 1 chloride. Copper with the Roman numeral 1 means that the copper ion has a +1 charge. And we're hooking up with chloride. Chloride is a halogen, so it usually has a -1 charge. So we just, in order to add up to 0, +1 and -1 does add up to 0 right away. So it's just 1 of each. So we just have 1 atom of copper hooked on to 1 atom of chlorine. So that's the reasoning behind that. How about dinitrogen pentoxide? Well, di means 2, right? So 2 nitrogen, so put a little 2 next to the nitrogen. Pent means 5, and ox refers to oxygen, so N2O5. That's not too hard. So that's the naming system when you have 2 nonmetals. Uh-oh, H in front. Acid alert. HF. Well, there's no oxygen there, is there? So we use the word hydro as our first term. So it's hydro something, right? And the F stands for fluorine. So hydrofluor. And then you put the ic after that root of fluorine. Fluor, ic. And then you write the word acid. Here's another acid, HNO3. But there's oxygen, so we do not use the word hydro. We look up NO3, that's a nitrate. We have to change the 8 to ic. So it would be nitric acid. Here's another acid, H3PO4. Has H in front, right? It has oxygen in it, so no hydro. We look up the polyatomic ion, that's a phosphate. Change the 8 to ic. It would be phosphoric acid. MnO2. There's a metal and a non-metal. Let's see where Mn is. Uh-oh. Red alert. Mn is a transition metal with a whole bunch of different possible charges. It could be a +7. It could be a +5, +4, +2, or +3. What is it in this case? Well, we know oxygen is a -2, and we have 2 of those. So 2 of those at -2 apiece gives us a -4. We have 1 Mn, so that 1 Mn must have a +4 charge in order to add to the -4, so it'll equal 0. We'll have a neutral compound. So the manganese then has a +4 charge, and so we indicate that with a Roman numeral. So this is manganese, Roman numeral 4, oxide. For the next one, metal, non-metal, simple case. Silver is a transition metal. However, if we look at silver, there's just one possibility, a +1 charge. So we do not need to use, oops, I spelled manganese wrong. I have to put an N in there. We don't use Roman numerals since there's only one possibility. So this would be silver. Instead of saying Roman numeral 1, we just say silver and then sulfide. Okay? So that's the logic. I'm going to go a little faster now. Here we have chromium 3 oxide. So we have chromium, right, Cr. It must be a +3 charge. And then oxygen has a -2 charge. We can use our crisscross rule. And so we get Cr2O3. Cr2O3. Sulfur hexafluoride. That'd be S. Hex means 6, so SF6. Supposed to be an S. Hydrocyanic acid. There's the word hydro, which refers to an acid without oxygen. Since it's an acid, it has H in front. Cyanic refers to the polyatomic ion cyanide, which is Cn. So hydrocyanic acid. Chloric acid, that's a little tougher. Okay, what we need to do is we need to look at the polyatomic ion chart. Remember, chloric was used when the polyatomic ion ends in ATE. So let's find a chlor with an ATE, and that would be chlorate, ClO3. So it's an acid with ClO3 in it. So we write, and it has a -1 charge, so that means we only need 1 hydrogen attached to it to make it neutral. HClO3. H2SO4, that's sulfuric acid. Pb, and then this one here, this is a polyatomic ion called acetate. Okay, now lead is a transition metal. We'll find lead here. And it has more than one possible charge that it could take on. It could take on a +4 or a +2. So we'd have to use Roman numerals for that one. So this would be lead. Now the acetate has a -1 charge, and there's 2 of those, so that means that this would be -2 here. That means lead needs to be a +2. So lead, Roman numeral 2, acetate. Phosphorus acid, that OUS, implies that the polyatomic ion had an ITE ending to begin with. So that would be a phosphite ion. If we looked on the polyatomic ion sheet, we can find the phosphite this particular one doesn't have it on here, but it'd be a PO2. So PO2 with a -2 charge, and so we could just write it like this: phosphorus acid. Okay, how about cesium perchlorate? Well, cesium is an alkali metal, so that's just a simple metal, Cs. The perchlorate ion, we'd have to look that up on the polyatomic ion sheet. Perchlorate is ClO4 with a -1 charge. So CsClO4, cesium perchlorate. Next one, tin 2 fluoride. Tin, if we look it up on the periodic table, is Sn, and it has more than one possible charge that it can take on, either a +4 or a +2. So we're going to have to use Roman numeral for that one, and it does, right? So what is it, a +4 or a +2? Well, let's just put a little over here. Sn is the symbol for tin. Fluorine has a -1 charge. So I'm sorry, we don't need to find out if it's a +2 or +4. We know it's a +2. So what's the chemical formula now? Well, if that's a +2 and fluorine is a -1, we need 2 fluorides at -1 apiece to cancel out that +2. So it'd be SnF2. Sulfur trioxide. Sulfur's a nonmetal, oxygen's a nonmetal, so that's why we use the mono-di-tri system. So that'd just be SO3. Li3N, lithium is an alkali metal, N is a nonmetal. So we just use a simple naming system of lithium nitride. KH2PO4. Well, K is potassium. I can write that down right now, and it only has one possible charge. The H2PO4, if we look it up on here, that's a dihydrogen phosphite. Okay, so we just write the name of that out. Dihydrogen phosphide ion. So I'll just write potassium dihydrogen phosphite. Titanium Roman numeral 4 nitrate, Ti, and then nitrate is NO3. But since this has a +4 charge and NO3 has a -1, we need 4 of those NO3s at -1 apiece to neutralize that one titanium at a +4 charge. How about HClO4? That's an acid because it has H in front, huh? The ClO4 is a perchlorate ion ending in ATE. So remember, we changed the 8 to ic. So this would be perchloric. Instead of perchlorate, we changed it to ic, right? Acid, perchloric acid. Oops, I forgot to put the L in. Perchloric acid. Here's one very similar looking, HClO3. The ClO3 is a chlorate ion. We changed the 8 to ic, and this would be chloric acid. And the last one here, hypochlorous acid, we look it up. That would be from hypochlorite, ClO, with a -1 charge. ClO with a -1 charge. And so we'd only need 1 hydrogen there. This is hypochlorous acid. Remember, if you have the OUS ending, that implies that we had a polyatomic ion with an ITE ending. Remember, ite, we change it to us. Okay, thanks everybody.